Hello, I'm Stefan Greber, project leader for LXD, and this is the LXD 5.11 release live stream. Just first thing first, because a bunch of people keep asking, the cat is actually on my desk. I'm just hoping as he moves a bit towards the pillow and you might actually see him. Alright, so more seriously, what's in LXD 5.11? This is a far more busy release than what we have put out for the past few, because the past two releases were around the holiday time, which kind of limited what was the amount of time we had to spend. Okay, so again, for anyone who wanted to see the cat, that's as much as you're gonna see, because it's just leaving the room. Oh wow. So this release is quite a bit busier. We got to actually include a few major releases in there. I'm gonna go through that. The first feature is the instance placement scriptlet. So over the years, we got quite a few requests to add more flexibility to LXD instance placement within clusters. But for anyone not particularly familiar, the way it currently works is that LXD simply counts the number of instances it has per machine and picks whichever machine is of suitable architecture and matches the right groups and has the fewest instances, and just goes there. It does not care at all about how much actual available resource there might be on the machine. It doesn't care about any kind of different hardware or any of that kind of stuff. It just picks whichever has the fewest instances. It doesn't even care whether the instances are running or not. We've had a number of different approaches suggested to us over the years. The most common probably was something along the lines of using an external scheduler or using maybe webhooks or something else that LXD would effectively call a script or would call a webhook to be told where to place things. The issue we have with those kind of approaches is that, first of all, within a cluster, it's not great to rely on things that are local to a system or things that need network hit in a pretty critical code path. So we never really liked those approaches so much, even though webhook was a bit closer to what we would have done. But recently, Canonical has been paying quite a bit of attention at what can be done with scriptlets. So it's effectively a small script that can run within an application. Specifically, LXD, we're looking at using Starlark, which initially started as a Java project to run a Python-style script inside of a Java application. But these days, Google has an implementation of it, which lets us do it from Go, and that's what we're doing in LXD. You can think of that as somewhat similar to what you might have done with Lua inside of a C program before. It really makes it possible to expose some amount of internal information, some amount of functions to one of those scripts that the user can easily swap out and like changing the core logic. So yeah, in this release, we've got a new config key. It's called instances.placement.scriptlet, and it can be set to a scriptlet, which, as I mentioned, kind of looks like a bit of Python. And we can just go look at that real quick. So we got the documentation. That's kind of what this looks like. We effectively define a function which is passed both the request and a list of candidate cluster members. And the function can then decide where to place it. So you can return an error, or you can set what target it's supposed to be using and then just return. And within that environment, you can look at the actual list of candidate members. So if you just wanted to pick whichever has fewest instance or something, you can do it that way. You can also look at the request to know what kind of devices and config keys and kind of the sizing of the instance from that request. But we also expose a few functions that you can call, specifically things like get cluster member state, get cluster member resources, and get instance resources. And that can be used to get a better idea of what kind of hardware is available on a given cluster member and what its current load looks like. This makes it pretty easy, for example, to pick whichever machine has the lowest CPU load, or whichever machine has enough memory for that instance, that kind of stuff. So those functions makes it pretty easy to access that kind of data. And as we see more people starting to use this mechanism, we'll no doubt be adding more data and more functions that can be used to pull some more internal details to make the decision. All right. And the actual result is Like there's an example here in our doc, which as you can tell is definitely looking a lot like normal Python. There are some restrictions, like you can't do loops, you can't do any kind of imports, you can't access anything on the local file system. It's definitely restricted, but it is pretty reasonable syntax that can be used to make those kind of decisions. All right, so that's the first feature. Second feature is support for block storage mode on ZFS pools. By default, ZFS, the way it works in LXD is that we create datasets for anything that's either a container or a file system storage volume. And we create actual block, so through zvol, for instances, for VM instances, as well as for block volumes. But we never really did the intermediate, which is to create a zvol and then put a file system on it. That's been requested for quite a while. We actually had an issue on GitHub. It was filed about 5 years ago, requesting specifically that. We just never, it was just never really a big priority for us, and nobody in the community did it until now. But we recently had a couple of cases that made this pretty attractive. One of them is for running Android containers. So that came to us from the Nbox team, where on their side they needed to be able to run run Android containers that require the use of ext4 within the instance to make Android happy effectively. I just saw the message about the mic volume. I think I just boosted it as much as I can. I don't know why any of those settings would have changed, but it's definitely possible that something changed. Yeah, I'm not sure. Let me just check if I'm just gonna make sure that OBS here is picking up the right mic, because that could be a problem if it's somehow picked up the wrong one. Yeah, it's picking up the wrong one. Well, let me fix that. That's unfortunate. Audio, what's going on? Why isn't it using? Yeah, it's definitely wrong. Okay, I have no idea when that changed. That's interesting. Let me just fix that. That shouldn't be too difficult. Input, use the good microphone. This one. All right, that should be significantly better. Sorry about that. It is a bit unfortunate that I only noticed this at this point in the stream. Especially because that's going to be quite a significant volume bump, I think, for some people. Just trying to remove the boost I put in a minute ago. There we go. All right. So that should be significantly better. Sorry about the sound until now. If you didn't really get to hear anything about the instance scriptlet, I'm sorry. We will be making a separate video on that later. Making sure that the microphone is properly selected that time around. Sorry. All right. Okay, so back on the ZFS pools and ability to use zvols for instances and for normal volumes. So one of the needs we had was Android, which requires ext4 to be happy. It's possible to run it on something else, but a bunch of tests and certification stuff will fail. All right. So this is something that we can fix by that option that lets us still use ZFS. It lets us actually mix and match instances that are based on dataset and instances that are based on a zvol. And the other thing, and that's what I'm going to use in the demo just in a little bit, is that it also allows for example, running a container that will run Docker. And then in the case of Docker, it's really not happy to run directly on ZFS. And it will work, but it's going to use the VFS backend. And the VFS backend is quite terrible because it forces every single layer in Docker to be unpacked separately. And yeah, just very wasteful on space, very slow. With this, we can now create a secondary volume just for Docker, still on the same ZFS pool, make it ext4, and then attach that as valid Docker inside the container. And that then makes Docker very happy. It can use its overlay to backend and everything just works. So this is definitely a very welcome addition. Then another feature we added is a new LXD cluster info command and matching API. This is actually showing us the result of one of those internal functions we added for the scriptlets. So I believe it's the get cluster member state. This particular function returns an API cluster member state struct. And that's exactly what we made available. And since we made it available over the API as well, we decided to make a command line that also show it. So it gets you pretty raw values on the system. Things like the 3 load averages, current memory, swap processes, and usage of the storage pools. And that can be quite useful, whether it's for monitoring or for you doing your own kind of schedule analysis on the side, or to just see the kind of data that we do give you when you use a scriptlet. Then we've added support for attaching instances to managed physical networks. This is a bit of a corner case, but effectively we've added the concept of physical managed networks in LXD quite a little while back, and those were necessary for Oven, where Oven needed to be backed, as in its uplink networks must be physical, either an actual physical NIC or a VLAN. And when we implemented that, we never really did the remaining plumbing to expose that to instances as well. But now we have, and that lets you actually create an instance specifying that you want to attach to an existing managed physical network, and then the instance will get that physical network passed to it. What's worth noting here is that because we're dealing with physical networks in the LXD sense of the term anyways, it means that only one instance can make use of that, because as soon as you have consumed the physical network, that device is now gone from the host and no other instance can use it until that instance is set offline. What I mean by that is don't put this in a profile, because if you do, you're going to have a bad time. Only whichever instance starts first will get to consume it and the rest will just fail. So there's something to keep in mind. And the last thing on the list is we reworked our documentation. So, it's been a very long process on our sides to kind of go section by section and making kind of everything line up. The latest one to be worked on has been the images documentation. So if we look at that, it now has the same layout as most of the other sections, with like a new about page, and a bunch of the existing information has now been properly split across the usual set of pages we have, as well as a bit more information and examples for how to use the command line tool. All right. So now to move on to the demo. Luckily, we've got the sound fixed for that, so at least that part is going to be more understandable, I think, than the beginning of the video. All right. So here I've got a LXD cluster running LXD 5.11. And as a reminder, the first feature on the list is the instance placement scriptlet. So right now, if I look at my instances, I've got 2 of them running. And if I was to run another instance, it's called just like a basic Alpine instance. Since I've got stuff on cluster 1, cluster 4, and my cluster has 5 members, it's going to be on either 2, 3, or 5, most likely cluster 0, 2. So let's just create that and see what happens. And there we go, it's on cluster 0, 2. And if I'm creating another one, it's probably going to be cluster 0, 3, which is just the basic placement that LXD has in place. Actually, it picks 0, 5 anyways. But yeah, it effectively goes through the cluster members in the order in which they were added to LXD and just spreads equally across them. Now, if we want to change that, what we can do is to config edit and then set a new config key, instances.placement.scriptlet. And then we need to write a tiny bit of Python. I'm not gonna do anything fancy because, well, this is just a very quick demo. So what I'm gonna do is define the function, which is instance placement. It takes the request. It takes a list of candidate members. I think that's what I needed for the definition. Yes. And then what I'm going to be doing is just shove everything onto the same machine. So we're going to do cluster 03 and set that's always the target, and then return. Not the most useful placement script for sure, but it should get the point across. Except I did something wrong, so let me just check what. Actually, let me look at the error. Maybe it's config parsing cannot set to what was the error? Return a non-key. That's interesting. Let me just check. I got it working on it. I would probably just messed something up. So the actual function definition as is seen in the doc is that. Looks like I got that one mostly right. Set target. Yeah, set target. Then the string of where I want things to go. That's fine. Did I get the config key right too? Instances, placement, scriptlet. I did. And yeah, you normally just do a return. Okay. What did I mess up? Kind of confused. That's pretty much exactly what I tried like 5 minutes ago, and that worked fine. Still won't save, huh? Instant. Nope. Oh, there's like a. I don't like nano. Maybe it's just the extra carriage return at the end that's screwing this up. Okay, let's try that again. Edit VI. All right, so instances dot placement dot scriptlet. Definition of the function, and for now let's just put in return, and this is still complaining. So confused. This was going perfectly fine 5 minutes ago. Is it just a misindent thing? It is not. Okay, well, fine. Let's do it as is listed in the example, which means take. I'm actually going to use the example verbatim just to make sure I don't mess anything up this time, because I probably did something stupid. Okay, dump that into this. And this time it works just fine. Okay. So I definitely did do something stupid on here. Now, I'm just gonna do what I wanted to, not return though. I'll just fix that. So set target cluster 03 and return. Okay, so that worked fine. It might have been the indent being off or something like that. Python is a bit picky about that. Okay, so def instance placement, request candidate members, we shove everything on cluster 03 and return. All right, so that looks good. Took a tiny while. Oh, did I miss the T? Haha, that could explain it, yeah. Thanks, chat. All right, so with this in place, now let's go look at the list of instances and launch a couple more. Normally at this point 03 would hit, well, cluster 03 actually, which happens to be the one we've hard-coded. So that won't really tell us anymore on this instance, but it should land on 03. It does. then create another couple more and just make sure that they land where they're supposed to. At this point, they should all land on 0.3. There we go. All right, so other than my inability to type, apparently, this works just fine. And I mean, right now the script is about as easy as it gets. It literally just shove everything on cluster 0.3, but you could totally have conditions on the request itself. I mean, something pretty simple like set target on cluster 0.1, I guess. Okay, that's bad. And now if we do launch foo, this should land on cluster 0.1. And it did. You could probably also look at things like the config, so you accessing .config and then looking at the specific config of the list of devices. Could look at how much memory is this instance allocated, and if it is allocated more than say a gig of memory, then place it on a machine that's got more RAM. That kind of stuff. There's quite a lot of flexibility you can put in there, and we'll definitely be looking at feedback for any kind of data that's required and that we don't currently expose, so that we can change that. There's another question about like what kind of can we do like regular expressions or something like that. I don't know exactly what's exposed as part of the built-in Python functions in Starlark. I suspect you should be able to do a .starts with. Is it in Python? I've not done Python in a while. So let's try that. Maybe this will work. I believe this is valid Python, maybe. As I said, I've not done Python in a while. So let's try, see if foo1 and foo2 land in cluster 1. If it does, then that part works too. Yep. Okay, so starts with, ends with works at least. I don't know what else Python usually has built in and how much of that might have been implemented within Starlark. So you definitely want to look at the Starlark documentation for those kind of things. But it is pretty flexible, at least on kind of those kind of things. And we can expose more functions if we need to. It's always a bit odd because then we end up exposing like what looks like a Python function, but from Go. So I'd rather not expose an entire regex engine that way. But hopefully there's enough stuff built in to kind of do what you want there. All right, so that was the first feature. Let's move on to the next thing. Next thing is block storage on ZFS. So for that, I'm gonna switch over to my local system here. That's the demo project that has nothing in it. So what we'll be doing is let's create a new instance. Let's call that Docker 01. It's that startup. And now do the new thing. So that's creating a new volume on a ZFS pool. Let's call it Docker and do ZFS.block mode true and size 20 gigs. Okay. And then add that to the instance. So that's the way we'll do that. With pool is default, source is Docker, path is var_lib Docker. Okay. Then we go inside of the instance and we can see 20 gigs mounted from a zvol on var_lib Docker. So that part worked just fine. And then you'd go and actually install Docker in there. And we'll just then make sure that it's using the correct VFS backend. So it just takes a tiny bit longer. All right. There's a question about whether the new announcement from Ubuntu apply to LXD containers as well. Gonna have to be slightly more specific on that. I'm not sure what announcement that's about. All right, so now Docker, and let's just do a Docker run hello world to make sure that it actually functions. And I forgot a tiny detail. Let me fix that. So when you want to do nested containers, it's a good idea to actually enable nesting. And I forgot to do that during the launch stage. So let's fix that. So in case you ever get that kind of error, that's most likely because you're trying to do nested containers and you forgot to enable it. All right, so let's try that again. Hello world. There we go. And if we look at this, not status, it's info, I think, in Docker world. It's Docker info, yeah. If we look in there, we should be able to figure out the VFS plugin. Is it further at the top? Storage driver overlay 2, there we go. So it shows that it picked overlay 2, which is what we want, and that it detected the backing file system as XFS, which effectively is ext4 in this case. So this worked just fine. And now you can run Docker fast and normal because it can use its overlay backend just fine. All right. So that was the ZFS block storage mode. The next one is the new LXD cluster info. So I'm back on my cluster here. If we look, the cluster I was using earlier, it's got 5 machines and can do cluster info and then pass the name of the machine you want, which in this case is the current one. So you can just check compared to uptime. The values mostly line up. They don't anymore because I waited a second or so, but close enough. And you can do the same thing on any of the others. So say pull from cluster 05 and you get the information from whatever cluster member you want. And again, this is primarily meant to show you what's available from the scriptlet. That's the information that you can use from one of those scripts to fetch the host information as well as the storage pool data. In this case, we can see only have one storage pool here called remote, and we can see the amount of used and total space. This is currently all showed as raw bytes. We might change that for the comments to just make it a bit easier, like the way we do with many other metrics. But within scriptlets, we're gonna keep it as raw bytes because that you can actually divide and parse and stuff, which is a lot less fun to do if we were to pass you a string. All right, so that's for cluster info. The next one is the managed physical network. So I'm back on my machine for that. And if we look right now at my list of networks here, I've got 2 bridges, a physical network card, and a Wi-Fi network card. Those 2 are not managed currently, as you can see. But let's create a managed network card based off my physical network card. So let's call it Fizz 10 GB because it's a 10 gig NEC. And I believe it's network is parent or uplink. I think it's network, maybe. So let's try that. And then type physical. And oh, it's parent. Okay, so parent. All right. And if we look now, we can see Fizz 10 gig. Physical, it is managed. State created with nothing using it. Now, if I wanted to create an instance that uses that, I can do so with 2204 U1 network Fizz 10 GB. And now we've got one instance using it. And if we go look in there, and you also notice that now that the container has started, the physical NIC itself is gone. So it was there before, but it's no longer in the list now. And if I go, enable the container and go look, it's got an if0 card in there. That's actually that physical network card. It won't get an address or anything because there's no cable plugged into it right now, but it is the same thing. All right, so I can stop U1 and it should see the network card return over to the host. There we go. Cool. And the last thing was the updated documentation on images, which I've gone through already. So that concludes the list of new stuff in LXD 5.11. There's also a fair amount of bug fixes and other changes that we've made. We keep improving our database performance and fixing a bunch of issues around that. So things should be even faster than in 5.10, which is always great to see. As far as rollouts, there was a tiny bit of bumpiness around a small regression that we noticed on Friday. That's now been fixed, and we expect rollout of 5.11 to hit stable users within the next 2 or 3 hours as far as the beginning of the rollout. It's a phased rollout as usual, so it's going to be taking 2 to 3 days before everyone everyone receives 5.11. All right. So the question around the Ubuntu announcement was around Ubuntu Pro security with the LXD server instances. I don't know exactly how that works. Hopefully it's better covered in documentation than what I know. I know you can enroll individual LXD containers into Ubuntu Pro if you do want to get that. Obviously, as it stands, I believe it will count as each container consuming one of the license as far as the server is concerned. So if you're just on the free personal plan, you're gonna hit your 5 count pretty quickly. I don't know if there's any provision for effectively enrolling just the host system and then having the containers not count. That would be nice, but I don't know if that's the case or how that works. I think it's probably best to go look at the documentation for Ubuntu Pro and potentially raise an issue or question there. Like I know there was some thoughts and some ideas a while back to try and make things like both LXD containers, but also Ubuntu VMs running on top of Ubuntu systems, and even Docker containers running on top of Ubuntu systems to have access to some of the Pro features automatically, so you don't need to provision them, and so that they might not count as a full system. But I don't know if any of that has actually been put in place already, or if it's still the plan. So it's probably best to reach out to those folks to figure it out. All right, so that's LXD 5.11. Gonna be rolling out pretty soon. Again, sorry about the audio issue at the beginning. For some reason, my machine decided to switch the microphone from the proper good ones that's right in front of me to a random headset that's happened to be on my desk. So it's kind of impressive that it picked up any audio at all, but yeah, definitely not the best quality at the beginning. So yeah, you can expect at least a video on scriptlet soon enough, because we can go quite a bit deeper into that and showing more useful scriptlets. I'm quite excited about that. And yeah, for the rest, it's a bit more straightforward, and I hope it's very useful to you. So if you've got any questions, you can leave them down below or hit the community forum. If you've got any issue with LXD 5.11 as it rolls out, it's usually best to post directly in the release post so that we can get notified pretty quickly and can catch anything there. So thanks for watching. I'll see you in the next video. Bye, everyone.